talking, and like literally he didn't make much quiet. So I was like literally like dying, trying not to like choke.
And then your eyes start watering because you're holding it in. It's so bad.
Man, we torture you guys.
Well, we are in a math class, I guess, so that's natural, right? So anyway, but. Okay. So let's take a look at what we're going to do today. Like I said, we're talking about solving quadratic inequalities and being able to graph them. Say again?
Yeah.
I did. Did you not? I'm sorry. Did I not get yours? I may have missed it. I was probably distracted. So, all right, let me come over and do that. Oh, yeah, real quick here, and then we'll get into this. Okay. Here we go. So, solving a quadratic inequality is not too bad as long as we're okay with solving just regular quadratic like equations and stuff. It's not that different. Okay, especially if we're familiar with other inequalities and stuff like that. And again, sorry for the crappy graph paper. I know the lines kind of disappear in some locations here, but we'll do our best with what we got, and then I'll try and print better graph paper in the future. Because I hate to just waste it all too. Throw it away or something. Okay. So we'll start here with just there's kind of two different ways we can solve a quadratic inequality. One is using a graph, and then one is also using kind of like algebra and stuff like that too. So we'll show you with the graph, and then we'll show it to you with algebra. So let's just jump right in here. So let's solve y is greater than x cubed. Oh, sorry, not x cubed. That's not a quadratic. X squared. Y is greater than x squared plus 3x minus 4. Okay. And so you can see why I wanted to refresh our memory a little bit about how we graph quadratics in the first place, because we're going to be doing that here today, right? So in the format that we're given here, we're going to probably need to use that negative b over 2a to kind of figure out where the vertex of this thing is going to be. So let's do that. So we'll say, okay, the vertex x value there is going to be negative b over 2a. And so what is our b value according to this quadratic inequality here? What's the b? 3. So it'll be negative 3 then over. And then what's our a value? 1. Yeah, the coefficient there is 1. So it'll be 2 times 1. And so we get negative 3 over 2. Yuck, it's a fraction. Okay. Okay. And then we'll also plug that into the inequality there to figure out what the matching y coordinate would be. So we'll just be like, all right, y is going to be then negative 3 over 2 squared plus 3 times negative 3 over 2 minus 4. So, my goodness, let's see here. I'll just use my calculator for this one. Okay, so let's see here. Negative 3 over 2 squared plus 3 times negative 3 over 2 minus 4. So negative 6.25. Okay. So that's going to be our vertex. Negative 3 halves, comma, negative 6.25. Excuse me. Okay. So I'll sketch that over here. Okay. Something like that. Something like that. Okay, so we got our x and y coordinates up there, our axes up there. And let's see, the graph, negative 3 halves, that's negative 1.5, so I'll just go over negative 1 and then half again. So again, there's 1, something like that, and that, and that, and that, and that, okay. Alright, so negative 1.5 and then down 6, so goodness, 1, 2, 3, 4, 5, 6, but then a quarter, so something like there. Okay. And so then, let's see here, to the left and right, we've got like -1 and -2. So I'm just going to plug -1 in here, so we get some more points, right? So if I plug in -1, it'll be -1 squared, 1, minus 3, so -2 minus 4 is -6. So -1, -1, 2, 3, 4, 5, 6, and then by symmetry, -2, -6 as well there. Let's plug in 0, that's an easy one. 0 will give us -4, so 0, 1, 2, 3, 4, and then, let's see here, so that's -3 then, would also be 1, 2, 3, 4, by symmetry there. Okay. I want to see if we can, let's see, is 1 going to give us, yes, okay, so 1 squared plus 3 times 1, that'll be 4 minus 4, so at 1 we're at 0, and then at -4 we'll be at 0 too, so there we got our zeros at least. And then I'll just sketch this graph. Oh, but I already made a mistake. When we go to graph an inequality, right, there's two different kinds of lines, or two different kinds of curves we can draw. We can draw a solid or a dotted. So if you guys remember, based on this inequality symbol here, should we draw a solid or a dotted line? Dotted, okay, why dotted? Doesn't have an equals to, right. So Mr. Meyer kind of already made a mistake here, but I can fix it. I'll just do it right over here. Okay, so this should be dotted here. Okay, like that. Okay, and then of course when we do inequalities, not only do the solid or the dotted, we also have to do the shading, right? We have to shade to determine whether we are going to what region, what area, is part of the solution here. So with lines, it's pretty straightforward. You either shade above the line or you shade below the line, right? In the quadratic, it's a little less straightforward, but it still kind of makes sense, okay? If we want to shade y greater than x squared plus 3x minus 4, where should we shade in here? Yeah, we're going to shade above the curve. Above the curve. So essentially inside the curve. Here's what we're going to shade. So it's like all this area right here gets shaded in. Okay, we shade in all the stuff inside the absolute value. Sorry, inside the curve there, not the absolute value, inside the curve. Okay. If you're ever unsure about where you're supposed to shade, so like let's say you get to this and you're like, that doesn't make a whole lot of sense to me, Mr. Whitmire. What's another way? Another option is you can pick a point. Pick a point that's inside the the parabola here. So for example, point 0, 0 is in the parabola. If you test the point 0, 0, okay, then we'll have 0 for the y coordinate is greater than, and it'll be 0 squared plus 3 times 0 minus 4, and so we'll have 0 is greater than -4. Okay, and then is 0 greater than -4? Yeah, and so since 0 is greater than -4, right, this point 0, 0 works. It's part of the solution, and so that's like, okay, that means we shade inside. If 0, 0 didn't work, what would we do then? Shade outside. Okay, like that. So that shaded area there indicates all of the possible solutions of this inequality. Okay. When you graph a parabola, a normal parabola, right, where it's equals there, that means that all the points on the parabola, all these coordinates, okay, the ones that we did find and the ones between those, okay, these are all solutions, but nothing in this region, nothing outside of that region. Okay. When it comes to inequalities, though, sometimes the border, sometimes the curve itself is a solution, right, when we have the equals to, but when it's not, we draw that dotted line. And then the shaded area, all of these solve that inequality. So any of the points you pick in here, if you plugged it into this inequality, would solve it and make it true. Okay? That's the idea there. All right? So let's try another one here. Okay. Let's solve y is less than or equal to -x squared plus 4 by graphing. Okay, let's solve another one here by graphing. All right, so Amanda, how can we go about graphing this one? Can you graph it from the way it's written right there? Do you have any idea about how we could graph this? What's that? Yeah, absolutely. Yep, we could graph it from the way it's written. Whereas before, right, we had to do the negative b over 2a. This one, we actually don't need to do that negative b over 2a. You could still use negative b over 2a if you wanted to, but how would you like to graph this, Amanda? What would you like to do? Well, so how would you go about trying to graph this? What would you maybe try and do here? Or what do you notice about it? Or are you not sure how to graph it? Okay, that's fine. So let's use that negative b over 2a that we did before maybe. So x equals negative b over 2a. Okay, so what is our value for b in this case, Amanda?
0.
It would be 0. Very good. And then what's the value for a? Yeah, negative 1. Very good. So 0 divided by a negative 2 is still going to be 0. So the x-coordinate of our vertex is 0, and then we'll plug that 0 into the equation here, so it's y equals negative 0 squared plus 4, so it's just 4. And so the vertex is at 0, 4. Okay. How else could we have gotten that vertex besides using the negative b over 2a, though? What else could we have done there to figure out that the vertex is going to be at that point? What could we do? Anybody? It doesn't have to be Amanda. What gives away? Look at the way that that's written there, right? That's written in like one of our kind of shift transformation kind of forms, right? That plus 4, what does that mean? What does that plus 4 mean we're going to do?
Go down, up 4.
Go up 4, right? So our vertex is just shifted up 4. Well, if you're starting at 0, 0 and you go up 4, guess where we're going to be? 0, 4, right? So there it is, right? So again, all of these strategies, you know, feel free to use any of them that will apply here. I know maybe that's too much to keep track of sometimes. You know, you want just one thing and that's something that'll work every single time. The x equals negative b over 2a, that will work every time as long as it's in the right format and stuff. But anyway, so yeah, we'll plot our vertex. 1, 2, 3, 4. There's our vertex. Okay, and let's pick some more points here. So I don't know, I'll plug in 1. So 1 squared is 1, negative 1 though, plus 4 is 3. So 1, 3, and then by symmetry, negative 1, 3 as well. Okay. You can also try 2. 2 squared is 4, negative 4 plus 4 is 0. So we got a 0 at 2 and a 0 at negative 2 as well. Okay. Alright, let's go to... so AJ, what kind of line should we use here? Should it be a solid or a dotted line when we go to sketch this out? Solid line. Solid line. Why? Got the equal to. Exactly right. The equal to. Okay. So connect the dots there. Okay. Very good. And then, let's see here, what side should we shade, or where should we shade? Let's go to Greg. Greg, where do you think we should shade in this case? On the outside, what makes you say on the outside here? Okay, it's less than, alright, so if it's less than, yeah, it's going to be on the inside this time too, because we also changed the orientation. Yeah, very good. Now, let's just check, let's like convince ourselves that's right. You notice that, again, the origin is inside, so let's plug in 0, 0 here. So we'll say 0 is less than or equal to negative 0 squared plus 4. And then when we simplify it, 0 is less than or equal to 4. Is 0 less than or equal to 4? Yes. And so that means this point works, and that means all the points inside that region then work. Okay? All right. Questions on any of that? Questions on any of that? So the solutions here are all those points that are inside that shaded region. All the solutions, all the points inside that shaded region. All right, let me have you guys try another one here then. So how do you guys try this one? So try this one. Solve X squared minus 2x greater than 15 graphically. Or wait a minute. Hang on a second. I think that might be beyond. Never mind. Hold on a second. I'm going to give you a different one. Different one. Sorry. I see what I'm doing here now. We're going to have you graph. Just have you graph. Y is less than x squared plus 2x minus 8. Sorry, I'm going to change that. So sorry, graph the y is less than x plus 2x minus 8. I see what I was doing now, and that's why I want to be careful here. So yes, graph that. Just graph that inequality, please. The quadratic inequality. I made an error earlier there. Give us a try here. Graph that y is less than x squared plus 2x minus 8. Okay, so I want to find that vertex first. You can use x equals negative b over 2a. Lower this down so you guys can still see the previous example. I do. Over there on the windowsill. No, it should be, there we go. Okay. 1, 2, negative 5. 1, 2, 3, 4. 2, 4, 8, 0. Okay. So we should get something that looks like that. Okay, your vertex is kind of low. -1, -9. Okay. Mine barely fit there. It did. And then as far as shading, where should we shade for this one? Yeah. On the outside. That's right, Carlos. On the outside of it. So something like that. Just like that. Okay. So I apologize too. I was using the wrong words here. All we're doing is really just graphing these inequalities. We're not really solving it. I mean, we're showing where the solutions are located, but we're not really solving anything per se. We're just graphing it. So all these here where it just said solve by graphing, we're just graphing. That's all we're really here. And solve that, really just graphing. Okay, so I apologize there. Okay, because now we're going to look at how to actually solve then a quadratic inequality. So let me show you what I mean by that. Okay, so actually you can just flip your paper over because there's a nice little blank spot there, and we can just look at that here. Okay, so let's say we want to solve the quadratic inequality, and we'll say we've got, here I'll use that, 2x squared plus x minus 4, and we want to know when that is going to be greater than or equal to 0. Okay. Now we're going to use it, we're going to solve it algebraically. That is using algebra. Okay. So, the way we solve this is actually pretty straightforward. We're going to solve, we're going to first find the zeros or roots, however you want to say it there, the zeros or the roots. Okay. So what options do we maybe have here to try and find the zeros of this thing? What's one thing we could use? One thing we could use here to find the zeros or the roots of this thing. Okay, we could graph it and then find where it crosses the x-axis. That's one option. Yep, we could graph it. Those of you that were here yesterday, what did we use to find zeros or roots yesterday? Things. What's that? The zero? Well, yeah, we've got. We would set it equal to, well, sorry, so it's equal to 0 right now. We don't need to find like the y-intercept or anything like that. For the quadratic formula, that's one option we could use here too, is the quadratic formula, okay, to get the zeros as well. Or we could try and factor this thing. So let's see if it factors first, right, because that's a lot easier than using the quadratic formula. Alright, so 2 times -4 gives us -8. Our middle number there is 1, and so we need two numbers that multiply and then make -8, but add to make 1, and those two numbers are? Yeah, there's none. Guess what? We get to use the quadratic formula. Okay, so it does in fact we have to use the quadratic formula. What's that? Okay. So here we go. So let's see here. It's going to be x equals -b, so that's going to be -1, plus or minus the square root of b squared, so 1 minus 4 times a, which is 2, times c, which is -4, all over 2a, so it's going to be 2 times 2. Okay, question?
I didn't realize, I thought in the, when we did that, put the x with the a, like, for example.
Oh, you see, so now it's like, yeah, mind blown, huh? Yeah, so this is nice, and I agree. This formula is very confusing. There's a lot of stuff going on. I was always like confused by the plus or minus in there, because I was like, how do you do plus or minus? It's got to be one or the other. How can you have both in there, right? They're opposite things. But then I understood, it's really just being lazy. You just got to break it up into two separate problems, really, and then go from there. So, yeah. No, when you use the quadratic formula, you're finding the x's that make this thing equal to 0. So you're finding their x values. X equals that. Okay. So anyway, now we simplify this. So let's see here. Negative 4 times negative 4 is going to be positive 16 times 2 is 32, but then plus that 1 there is going to be square root of 33. All over 4. So that means we have our two zeros of negative 1 plus the square root of 33 over 4, and then negative 1 minus the square root of 33 over 4. So those are our two zeros. Okay, those are our two zeros there. So there we found the zeros. Okay, check, we did that. And I'm going to put those as decimals because it's a little bit easier for us to describe things here. So the negative 1 plus the square root of 33 over 4 is approximately 1 point, let's see, what did they round to? Two decimal, they round to 2 decimal places. So 1.19 we'll say there. And then the negative 1 minus the square root of 33 divided by 4 is approximately negative 1.69. Okay, so step 1, we find the zeros. Either, and I'll give you, I'll say here, factor or quadratic formula. Make sure equals 0. Okay. Number 2. We're going to draw a number line draw a number line containing those zeros. Okay, so number line. And we're going to put the zeros on there. And you're allowed to be kind of lazy here. So I'm going to put the negative 1.69 here and the 1.19 here, and I'm not going to worry about other numbers between or anything like that. Okay, we're not going to worry about trying to like evenly space things out so that it like goes exactly right. We're just going to say, well, the negative 1.69 will be on the left, the 1.19 will be on the right because it's negative and positive, right? Okay, since our original inequality symbol was greater than or equal to, at those points we're going to put solid dots. Okay, right? Since it's greater than or equal to, at those zeros we're going to put solid dots because those two values approximately give us a 0, right? Those are the zeros. So these things, when I plug them in, they're going to give us equal to 0, which is okay. And now you'll notice how many intervals did those two numbers break up our number line into. Those two zeros broke up our number line into how many intervals? More than 2. You got 1, 2, 3. There's 3 intervals there. And so what we're going to do is we're going to pick a number in each interval to then plug in to check to see if it makes our inequality true or false. That's all we got to do. So then try numbers from each interval in the inequality, and by try you could say test. Try numbers from each interval in the inequality to see if they work. Okay? So if we want to test a number in this interval, a number in this interval, what would be a good number to pick? Yeah, negative 2. Okay? So we'll try negative 2. So if we plug in negative 2 here, we're going to get negative 2 squared, which is 4, times 2, which is 8. So we'll get 8 plus the negative 2 minus 4. And we want to know, is that greater than or equal to 0? So we'll just try that number back in there. So 8 plus negative 2 is 6, minus 4 is 2. Is 2 greater than or equal to 0? Yes. So that interval works. What's a good number to pick in this interval right here? Yeah, let's do 0. So easy. Okay, if we do 0, it'll be 0 plus 0 minus 4. So we'll say negative 4 greater than or equal to 0. Is negative 4 greater than or equal to 0? Nope. And so we're not going to include that. Again, we chose 0. 0's in this interval. We're testing it. We test it back in that inequality. 0 squared is 0 times 2 is 0 plus 0 is 0. So it's just minus 4 there. Negative 4 is not greater than or equal to 0. So that interval doesn't work. And then you guys can probably guess, next interval, is it going to work or is it not going to work?
Yeah.
It's going to work, right. But you still should test it because there are some situations where they won't alternate, right? Here it alternates. Works, doesn't work, and then we want to say it works. And it will. But there are situations where you can go like works, doesn't work, doesn't work. Like you can have that happen. So you need to test all the intervals here. All right, so what would be a good number to pick here to try? 2. Yeah, 1's not quite big enough, right? 1 would still be over here. So yeah, no, that's okay. That's why I asked that question, just to make sure we're all on the same page. Okay, so then 2 squared is 4, times 2 is 8, 8 plus 2 is 10, 10 minus 4 is 6, so is 6 greater than or equal to 0? Yes. And so then we can finally finish our graph by, shading in the appropriate direction. Then don't forget the arrows too, because that indicates it keeps going that way as well. So that's also how we need to be able to solve those quadratic inequalities. Okay. You guys ready to try one on your own, or do you want me to do another one? I'm going to try one on your own? No? Yes? Alright, I'll do one more here, and then I'll get you guys started on an assignment. Okay, let's try another one. This will be the last example, and then I'll have you guys try one. Let's, again, solve x squared minus 2x greater than 15 algebraically. Okay. Alright, so what's the very first thing that we should do here with this quadratic? Yes, it's got to have a 0 there, so we're going to subtract 15 from both sides. And so we end up with then really x squared minus 2x minus 15 is greater than 0. Okay. Now, the first thing, now that we've got it equal to 0 there, we've got the 0 on the side there, okay, we want to find the zeros or the roots. Okay, so we're going to find those zeros. So again, I'll write that here, find the zeros. And we can do that by factoring. We can complete the square. We can use the quadratic formula. Okay. Does this thing factor? Does it factor? It does. Okay. Negative 5 and what? There you go. Yeah, it does factor to x minus 5 and x plus 3. Right? Two numbers that multiply to negative 15, but add to make negative 2. That would be 5 and negative 3 there. I mean negative 5 and positive 3 there. Okay, so it does factor. And so I'm going to go ahead and just find the zeros. So that means the zeros are x equals 5 and x equals negative 3. Okay. So there we found the zeros. Next thing we'll do is draw our number line. Okay. So negative 3 and 5. What kind of dots should we put at the negative 3 and the 5? Should they be filled in or should they be open? Greg says open. Okay, yes. And why do they need to be open here, folks? We don't have the equal to. So open circle, open circle. And now we're going to test our intervals here. Okay, so test the intervals. Okay. And oh day. how about Katie? What's the number we can pick in this interval right here? Sure, let's test -4. Test x equals -4. Okay, so we'll plug -4 in here. Let's see, -4 squared, 16. And then -2 times -4 is going to be positive 8. So it'll be 16 plus 8, which is 24. Minus 15 is 9. Is 9 greater than 0? The answer is yes. So this interval works. So you can go ahead and just shade that direction there and kind of color in the arrow too. Okay. What about in this interval right here? How about Carlos? What's the number we can pick in this interval? Yeah. I'm going to use 0 because like super easy to do math with a 0. So then we'll test x equals 0. 0 squared is 0. Minus 2 times 0 is still 0. Minus 15 is -15. Is -15 greater than 0? Nope. And so we don't shade any of this here. And let's test, let's test x equals 6 here. 6 squared is 36. Minus 2 times 6, that's 12. So 36 minus 12 is 24. 24 minus 15 is 9. Is 9 greater than 0? Yeah. So we're going to shade that in and shade in the arrow there too. And there are our solutions. Okay. So the solutions for this inequality are any numbers to the left of -3, right? So from -infinity to -3, or from 5 to infinity. Those are all the solutions. Any of those x values will work. Anything between -3 and 5 will not work, including -3 and 5. They also do not work because they're excluded. Okay? That's that. So what I'm going to assign then is I'll give you just a few problems for homework. I'm going to give you like 4 problems for homework. Okay? That's it. But it is going to be out of this green book, so you're going to need to take a picture, all right, if you don't get it done here in class. Okay? You're going to need to take a picture if you don't get it done here in class. So, let me put this up on the board here for you. Starts on page 304. Okay, how do you numbers? Number 10. Actually, sorry, 8 and 10. 8 and 10.
Last second.
And then 47. And 50. Okay, so just those 4 problems. Okay, that's it. The first 2 are just graphing the inequality. 8, 10, 47, 50, yeah. Okay, so that's just graphing the inequality, or the quadratic inequality. And then the 47 and 50 are solving the quadratic inequality using a number line. I'm going to use a number line there to help you. Okay? Alright, so you got 4 days this weekend. You can do a problem a day.